Hi everyone, I hope everyone's okay and safe and not going crazy with staying home, and hopefully you're all getting some fresh air. And I have been sitting here really brainstorming, trying to think how to go about delivering the end of our curriculum, because I do have hope that the AP board is going to try to do something where you guys can take the test at home if it gets to that point. So I really don't want to drop the ball. That being said, hopefully you guys get out, get some fresh air, and now have some time to digest the area between the curves. I did do that whole Khan Academy setup, but I really am not loving what I'm finding on there that I think that all of you will completely understand. So I'm going to attempt this first, and you let me know if this helps or not. So we've learned about the area between curves, and we already learned what I call the basic examples, where you have the two functions and you're able to draw the sketch and find the boundaries, and everything is in reference to dx. So I'm going to go over everything that I think that we need, and we're going to talk about the harder problems, which are the horizontal rectangles, which you'd probably by now have already seen a video on. But again, I figured it might be easier if I just explain in my words. So area between the curves, the first thing that I've always said is, number one, you want to sketch the givens. Number two, you want to decide which rectangles will be drawn. If it's going to be a vertical rectangle, your function will look something like this, where you have one curve and another curve that bound each other, and you're able to draw this vertical rectangle that you see here. And the only way that you know you can do that all the time is making sure that that top of that rectangle is always on the same function, and the bottom of the rectangle is always on the same function in that shaded area, in the area that you want to find. So that's that's what I call a vertical rectangle. And if you're drawing a vertical rectangle, the variable of integration will be dx. Now, what we're going to really do today is talk about, do we have to draw a horizontal rectangle? A horizontal rectangle, your sketch is going to look something like this, where you might have a sideways parabola and a linear function. If I tried to do a vertical rectangle on here, the top and the bottom would be the same function, and that can't be, because remember, we're taking the top function usually in this scenario and subtracting it from the bottom, and then we'd be left with nothing. So in this case, it makes us have to draw a horizontal rectangle. And if you see that horizontal rectangle, it's going to be no longer top minus bottom, it will be right minus left. You just want to make sure that throughout this entire shaded region, the horizontal rectangle is always, the right side of that rectangle is always touching the same function, and the left is always touching the same function throughout, which is the case. And then what you see here is that if we draw a horizontal rectangle, the variable of integration will be dy. Okay. So now, once you've decided what rectangle you're going to draw, a vertical or a horizontal, you want to make sure your equations are appropriately written. If you're drawing a vertical rectangle, the equation should be y equal form. So you'll have the two equations, y equals this, y equals that. Everything will be in terms of x. And your integral is going to be top minus bottom, and your variable of integration will be dx. If you're drawing a horizontal rectangle, the equation should be x equals form, and your integral will be right minus left dy. Now your bounds, if it's dy, these bounds will be y values. If it's, as you see up here, dx, these bounds will be x values. All right, so that is what we're going to talk about today. The last step of finding the area between the curve is step 4. After you've decided which rectangles you're using and the equations are in the correct form, now you find the bounds by setting the equations equal to each other. And after you do that, you set up your integral. Okay. So this is going to be the first example of what we will have to use a horizontal rectangle. Here, it says find the area between this and this. at this point, you should feel comfortable with your equations and seeing that I see one variable squared. I know this is a parabola because the other variable is raised to the first power. And I know this is a sideways parabola because y is squared and not x. That being said, I want to sketch it. That's always my first idea that you should try to do is sketch the curves. If I want to sketch this, I'd like to get this in the form of x equals. So I go ahead and add the x here and subtract the y, and I get x equals 5 minus y squared. In this case, it's almost solved for x. I just need to get x by itself by dividing by 4, and I get that x is equal to 1/4 y squared. So now I have my two functions, and I'm looking at this, and this is the same thing as x is equal to negative y squared plus 5, and this is x is 1/4 y squared. Why did I do that? Because I'm very familiar what a negative y squared parabola looks like, and that it's been shifted to the right 5. So I draw my picture. That's the first thing I want to do. And when I draw my picture, again, parent graph opening to the left and then to the shifts over 5. 1, 2, 3, 4, 5. There is my first function, which I'll actually try to make in red so we can distinguish between the two. And say you're not sure, how did I know it went over that way? You could always plug in 0 for y and see what x value it's going to give you, and the point would be 5, 0, which is right here. Okay, when I do this, I know this is a parabola that opens to the right because it is a positive y squared, and then there's been some sort of shrink here. So I'm just going to give this a sketch, and that second function looks like so. So now when I'm looking at this area that I've captured in here, I cannot do a vertical rectangle because if I did, the top and the bottom would be hitting the same function. So I go, oh, this is a problem where my rectangle must be horizontal. And if my rectangle is horizontal, then I know my equations have to be in the form of x equals, which I already have, and I'm ready to find the bounds. I also know that my integral, when I set up, it's going to be right minus left, and the variable of integration will be dy, not dx. Okay, so finding our bounds. We know, so just let's go back through that list. We sketched this. We've decided what rectangle we want to draw. It's a horizontal. We have our equations in the correct form, and now we're on to step 4 where we're just finding the bounds, and we do that by setting the two equations equal to each other. Negative y squared plus 5 equaling 1/4 y squared. If I have this, I'm looking at a fraction that I definitely don't want to work with. So I know from algebra, if I want to not work with this fraction and I have an equation, I can multiply everything by that denominator 4. And then I get negative 4y squared plus 20 is equal to that 4 crosses out with that 4 in the denominator, and I just get y squared. Now I'm continuing to try to find the bounds, so I'm adding the 4y squared, adding the 4y squared, and I get 20 is equal to 5y squared. So now I'm here, and I'm just looking at what time we have. Hold on a second. Oh, I still have time. All right, I'm on a 15-minute limit here. So we got 4 is equal to y squared, square root, y is equal to plus or minus 2. All right, these are my bounds. When I set up my integral will now be 2 and negative 2, which makes sense right here. And it's going to be right minus left. If you see, my red function here is the right function. So I'm going to use this first. And just like our trick before, if we can't sketch it or we're not sure, we want to double check, you can pick a number in between these bounds. And if I plug in 0 and I put it into the first function, I get 5. If I plug in 0 in the other function for y, I get 0. 5 is bigger, so that's going to come first. So it's right minus left, so this is just 1/4 y squared dy. This is now the correct setup. From here, you should be okay. 2 to negative 2, we get negative y squared plus 5. minus 1/4 y squared dy. I want you to combine this and then go ahead and integrate. I'm going to stop the video for right now because, as I said, it's a time constraint. I want you to try this. I'm going to post the solution to this problem via picture, and I'm going to give you an assignment. Hopefully this helped. We're going to get through this. Bye.